So here's example 2. It says find the derivative of y equals x e to the x. This is a perfect example of what I was talking about, where we are forced to use the product rule because the first function here is x, the second function here is e to the x. Again, you want to do the first, which is x. The derivative of the first, well, the derivative of x is just 1. We want to do the second function is e to the x. We want to do the derivative of the second function. Well, the derivative of e to the x is just e to the x, right? So what's the product rule? If you remember the product rule, it tells us that y prime is 1d2 plus 2d1. First times the derivative of the second plus the second times the derivative of the first. Well, what's that look like? Well, with the math that we've done, it's 1d2 plus 2d1, if you see my arrows going across. So this would be first, which was x, times the derivative of the second, which was e to the x, plus the second function, which was e to the x, times the derivative of the first, which is just a 1. Simplifying this a little bit, I get x e to the x plus e to the x. But what I notice here is I can factor out an e to the x. And these are the only problems that I'm going to ask you to factor is when it has an e to the x. The rest of them, you can leave them distributed. The only time I absolutely need you to factor is if it has an e to the x in it. So I can factor out an e to the x in this. X e to the x divided by e to the x is just x. And e to the x divided by e to the x is just a 1. So it factors into e to the x times x plus 1. E to the x times the quantity x plus 1. So y prime is e to the x times quantity x plus 1. Okay, let's move on to example 3 here. It says find the derivative of 2x cosine of x minus 2 sine of x. Well, if you look at this, we actually kind of have to do this in two parts. We have 2x cosine of x, which is going to be a product rule, and then we have minus 2 sine of x. Well, that's just a constant multiple times sine of x. So for the second part, we don't need the product rule, but certainly for this first part, we do need the product rule. So I'm going to go ahead and pull this apart. The first function here I'm going to call 2x. The second function here I'm going to call cosine of x because it's the product of two functions. Again, you need the first, which was 2x. The derivative of the first, well, the derivative of 2x is 2 times 1, which is just 2. We need the second, which is cosine of x. Then we need the derivative of the second. The derivative of cosine of x is negative sine of x. And again, the rule says you do 1d2 plus 2d1. So y prime is going to be equal to 1d2 plus 2d1. That gives us the derivative of the first part minus, well, we still need to take the derivative of 2 sine of x. So I'm just going to use some horrible notation here. I'm going to put that in parentheses and put a prime after that to say just mentally, look, I still need to find the derivative of that part. Okay. So y prime, first function was 2x. d2, the derivative of the second was negative sine of x. Plus the second function, which was cosine of x, times the derivative of the first function, which was 2, minus, what is the derivative of 2 sine of x? Well, that would be minus 2, well, the derivative of sine of x is cosine of x. Okay, so let's clean this up. I would have 2x times negative sine x is negative 2x sine x. Then I have plus 2 cosine of x minus 2 cosine of x. Well, what do you notice happens when we're simplifying? The plus 2 cosine of x and the minus 2 cosine of x are going to cancel, and I'm going to end up with my derivative being negative 2x sine of x. So I used product rule for the first part and then just straight up constant multiple rule for the next. I have y prime equals negative 2x sine of x. Excellent. Let's move on to the next rule, which is the quotient rule. Again, derivatives come from limits. Limits do have rules. A rule for the limit of a quotient is the quotient of the limits, meaning find the limit of the top and find the limit of the bottom, plug them in, and you have the limit. Well, that does not work for derivatives. The derivative of the quotient is not the quotient of the derivative. It most definitely is not the quotient of the derivatives. So I want you to go on to the e-text again, and in the textbook it works through the entire proof of it. Really cool proof of it where they add and subtract the same function, allows them to separate and simplify. Is really cool trick into finding the definition, or using the definition of derivative to find the quotient rule. It's not required for this class. I'm not going to make you do the proof in this class. I'm going to get you to the rule, and you most definitely need to memorize the rule. So what's the rule? It says the derivative with respect to x of f of x over g of x is g of x times f prime of x minus f of x times g prime of x all over g of x squared. So what am I going to do? I'm going to call it the low function and the high function, and then I'm going to call it the derivative of the low function and the derivative of the high function. Okay, so if I look at this, it's g of x is the low function, f prime of x is the derivative of the high function, minus f of x, which is the high function, times g prime of x, which is the derivative of the low function, all over g of x, which is the low function, squared. So what do you get? You get low d high minus high d low over what's below squared. So that's how my students have memorized quotient rule over the last 14 plus years of teaching this class, is low d high minus high d low over what's below squared. Low d high minus high d low, low d high minus high d low over what's below squared. So how do you do this? Find low, d low, high, d high, and then plug it into the formula. Simplify, okay? One huge thing that I want to say here is when you do this, do not forget to distribute the negative. So what am I talking about? When you plug it into this formula, without a doubt, you want parentheses times the high times d low. And you've got to distribute that negative to each one of those terms when you do that, okay? So be very careful about distributing the negative in the second half. That's the number one mistake when people try simplifying with the quotient rule. So let's look at some examples of this in action.